Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology. Subject code OMD 551, Unit 3, Topic Impedance Matching Circuit. Objective to learn about the concepts of impedance matching circuit. Impedance matching circuit. Here the term impedance matching is rather than the straightforward. That means it's simply defined as the process of making one impedance look like another, and it becomes necessary to match a load impedance to the source and the other internal impedance of a driving source. Here also we have a wide variety of components and circuits that can be used for impedance matching. This series summarizes the most common impedance matching techniques. Next one, nationally and concept. Here the maximum power transfer theorem says that it transfers the maximum amount of power from a source to the load. It shows in the circuit diagram. Then the load impedance, what they will do means it should match the source impedance in the basic circuits. That means a source may be DC or AC and its internal resistance Ri or generator output impedance drives a load resistance or impedance ZL. Here the maximum power is transferred into a source to a load when the load resistance equals to the internal resistance of the source. Here it varying the load resistance on a source shows that maximum amount power to the load it is achieved by the matching load and the source impedances. Here it shows the performance curve also. That means a key factor of this theorem is that when the load matches the source, then the amount of power delivered to the load is the same as the power dissipated in the source. So here we can do a transfer of maximum power is only 50% efficient. Then the source must be able to dissipate the power. Here to deliver the maximum power to the load is the same as the generator, and you have to develop the desired output power. Then we have types of impedance matching circuit. First one is transform matching. Here RF transformers can be used to provide very wide band impedance matching. Here the main limitations are the restricted range of available impedances and the frequency limitations on transformers. Then the next one is LC matching. Here inductors and capacitors are used to affect the impedance transformation. LC matching results in a relatively narrow bandwidth match, and it also very practical at frequencies from 30 MHz to 300 MHz. The next one is transmission line matching. By using a transmission line of a required length and the characteristics impedance, here it required the composite match can be obtained. Such a match tends to be a broader frequency range than LC matching, and it can also be applied to frequency above at 150 MHz. Then the next one is capacitive impedance transformer. Here this impedance transformer is not included in AN267. Why? But this network can be quiet. It is very useful and give very reliable components in interstage matching networks. Here the network is thus used to match the output impedance of one transistor to the input impedance of another transistor. Then the circuit is placed to the low pass PI network and except the ground and the input port are changed. Then the network and the output impedance at port 2 is always larger than a port 1. Thank you.